Hey there, AP Bio, and welcome to our discussion on Chapter 42, where we're getting into ecosystems and energy transfer. So we're going to be starting off with 42.1. And the biggest thing we need to know is looking at some principles from physics, the law of conservation of matter and energy. So what this says is that in a closed system, matter and energy can neither be created nor destroyed, but must stay constant. So what does that mean? That means that energy can transfer from one form to another, but it can't be added. You can't add to it or make more energy in a closed system. The only way to do that is to add energy. So, looking at Earth, the only way we get more energy is by that solar radiation coming in and giving us more energy. Same thing with matter. You can't make new atoms in a closed system. However, that matter can be transferred and recycled. And so we see that with what you eat being broken down, and then those atoms being reutilized and repurposed into making more of you. As we look at these laws of conservation and we start applying that to our food web, we can see how these energy and matter starts to flow through our system. And so in order for our planet to function, we need to perpetually be adding new energy into the system to power our primary producers or our plants. And so that's going to be coming from the sun. That's going to then go to our primary consumers, which is going to go to secondary, tertiary consumers. You're going to have things dying, and those are going to get eaten by decomposers and detritivores that are going to recycle some of those nutrients and energy back into the soil. A lot of stuff is going to be lost due to heat and respiration. And so we're going to lose a lot that way, and that's why we have to keep pouring in. So we have, just as a reminder, some of our trophic levels as we go through it. Producer, energy is entering from the sun. Plants are using photosynthesis to make sugar, make energy. Those are going to get eaten by primary consumers, those herbivores that are going to eat plants, algae, or lichen, any of those photosynthesizers. As we move up the food chain, you're going to find a secondary consumer. These are carnivores that are going to eat those primary consumers. Sometimes you might find omnivores where they eat those primary consumers but also eat plants. So they're kind of both that secondary and primary consumer. As you move further up, you're going to find larger predators that are mostly just going to be predators. They're eating secondary or primary consumers. And so these are typically exclusively carnivores. As you get all the way up, you're going to end up with an apex predator, which is something that nobody eats it unless it has died. So it's not getting hunted. But that's where we start to see some detritivores come in, that they are going to be scavengers that are eating detritus or dead organic material. So things like earthworms turning leaves into soil, things like vultures that are picking away at carrion. And then we have decomposers. These are going to be things that are breaking down organic material and returning these nutrients back into the soil to be used by plants. So things like fungi, things like bacteria are going to be our decomposers. Even though it seems very similar, understanding the difference between a detritivore and a decomposer is very important. Rolling right into chapter 42.2. We're talking about productivity here. So ways that scientists are going to be measuring productivity or how much energy is entering an ecosystem. We are going to keep track of how much energy enters the ecosystem so we know how much it can flow through each of those trophic levels we just talked about. So we can measure this in two ways. Gross productivity is the total amount of energy that actually gets brought into the system. So how much energy is harnessed by those plants from the sun. And net productivity is how much is actually converted into something useful. So those sugars are being converted into a growth, for example, as opposed to being lost due to respiration, being lost due to heat, being reflected back into the atmosphere. So net is going to be a little bit more useful for us because it's telling us how much is actually being utilized in our system. And as we're talking about productivity and the ability to grow and do something biologically useful, it's important that we explore the concept of a limiting nutrient. So you can think of this as you own a bakery, you want to make a bunch of cakes, and so you can see all the ingredients there for a cake. You may have infinite amount of flour, you bought all the sugar you'll need, all the milk and butter and baking powder, but you only have 2 eggs. So you're not going to be able to get very far if you only have 2 eggs. Eggs are our limiting nutrient, what we is in the least amount of supply, and in order to make more cakes or in order to have more biological activity, we're going to need more eggs. Someone's going to have to make a run to the store. Typically in nature, this is going to be nitrogen and phosphorus are our limiting nutrients. You can see in this experiment here of growing these grasses, the red line, the control, nothing was added. You can see the blue line, phosphorus was added, the black line, nitrogen was added, and when both are added, you see a really strong increase overall in terms of biomass, the amount of plant that was able to grow. So most commonly, nitrogen and phosphorus are going to be our limiting nutrients. We'll explore that in our next video when we're talking about those energy cycles.